Okay, this video is for exam 4, page 3, section 1, and we will be starting. So, compute the following defined integrals. So right here we have integral of lower bound 1, upper bound 16 of 4 minus 1 over x plus 3 over 2 root x dx. So the first step is for this one is to take the integral as normal. So integral of this would be 4x minus ln of absolute value of x plus, and this is a bit going to be tricky, 3 halves of root x divided by 1/2 on over 16 1. And we will simplify this a little bit by having the 1 over 2 be multiplied by 2. So we are going to have 4x minus ln of absolute value of x plus 3 root x of 16 to 1. And now we use the equation of upper bound minus lower bound. So in this case, the equation will be 4 times 16 minus ln of 16 plus 3 times root 16 minus 1 minus ln of 1 minus 3 root plus root 1. So that is our equation. So once we add all these together, we get 76 minus ln of 16 minus 7. And that will give us 69 minus ln of 16. And that will be our answer for A. Next up, B. Alright, so for this equation, it asks us for the bound of lower bound of 0 and the upper bound of root pi over 3 of x sine x squared over cosine of x squared dx. So in this case, our u is going to be equal to cosine of x squared. So that means that our du is going to be equal to a negative sine x squared times 2x dx. So our dx is going to be equal to du over negative sine x squared times 2x. However, what we also need to do is we need to change our bounds. So because our bounds is 0 to pi, so we need to now change it corresponding to what our u is. So u of 0 and u of root pi over 3. So this is cosine of 0 squared, which will be 1. And this is cosine of root pi over 3 squared, which equals 1/2, because the square gets rid of the root, and cosine of pi over 3 is 1/2. So we shall rewrite our equation as 1/2 over lower bound is 1, upper bound is 1/2, and x sine of x squared over u times du of negative sine x squared times 2x. So the signs cancel and the x cancel, so we're left with du over negative 2, and we're left with 1 over u in this case. Now what we also need to do is we need to change our bounds, because our lower bounds is 1 and our upper bound is 1, so we need to flip them, because the smaller number should be at the bottom and the larger number should be at the top. So first things first, we're going to move our 2 to we're going to move our 1/2 to the front, and since we have to flip our bounds, we are going to multiply it by negative 1. So it becomes negative 1/2 of 1/2 of x of, sorry, not that, of 1 over u du. Actually, no, we do have a positive in this case, yes, because our negative sign was there. So yes, it was supposed to be positive. Sorry for that. So yes, we have 1/2 of upper bounds 1, or lower bounds 1/2 of 1 over u du. So now we take our bounds, which will be we take our integer, which will be 1/2 ln of absolute value of u plus, and then actually no, we won't have c in this case. Yes, for neither this problem nor the previous problem we will have c, because our integrals are defined, so we won't need a plus c. However, what we will need is the 1 over 1/2, because we need to calculate the upper bound minus the lower bound. So we are going to make it a bit easier, since we since both of them are going to have 1/2, we're going to do ln of absolute value of 1 minus ln over of 1/2 all over 2. Now ln of 1 equals 0, so our final answer is going to be negative ln of absolute value of 1/2 over 2. And that is our final answer. Next up is question 3. Now question 3 starts off a bit tricky, but we can do it. First things first, since our valence has a negative, once has a lower bounds of negative value and an upper bounds of a positive value, we need to check when those values, well, actually no, it's not that. It's more so the fact that this equation has an absolute value. So we need to change. We need to see when suddenly the slope changes of that graph, so we know when those two need to be added. Because if we do our bounds like normal, we would have an inaccurate bounds, because it would seem like if the bounds was below the the graph instead of below the x-axis instead of on top of it. So first things first is find out what t equals to. So 2 plus 2t equals 0. So 2t equals negative 2, and t equals negative 1. And then, so we see that, and we're going to put a number line for our bounds to see when the graph is negative and when it's positive. So our end bounds is negative 2 and 6. So f of 1.5, not the prettiest number, but we have 1.5, our value is going to be negative 1.5, sorry. If we put this inside, we'll see that our value is going to be negative for this equation. Our 2 plus 2t. And for this one, it's going to be positive. So we can see that we need to split our equation for this bounds, this integral into negative 2, 1 and negative 1, 6. And because our first bound is negative, let me put this to make sure. Because our first bound is negative, we need to put a negative in front of the bound. So negative integral of negative 1, negative 2 of 2 plus 2t dt plus bounds to 6, lower bounds to negative 1 of 2 plus 2t dt, and then we do the integral and solve for both of these. So we're going to have negative 2t plus t squared into negative 1 to negative 2 plus, same as the previous one, but instead of negative 1 to negative 2, (-2 to (-1), or in this actually, it's going to be (-1 to 6). So now we need to calculate this, which is going to be this will take a little bit of time since we are solving for 2 integrals instead of 1. So we're doing upper bounds for this one and lower bounds. This is the next part we're going to do, the lower bounds. And now for this part, we are going to do this other integral, which will be (6 plus squared minus 2 (-1) plus (-1) squared Alright, and then we add all these together, so (-2 plus 1 is 4 minus 4 plus 12 plus 36 plus 2 minus 1. And so we're going to end up with 1 plus 49. And so our final answer will be 50 for question C. Alright, that was all for this page. It was quite a bit of a long and quite complicated for each of these problems, but that is all. Alright, and that is the end of this video. Bye.